All right, so without further ado, I just ain't had anything going right this morning. I might as well quit. There we go. Okay, are you going to start or not? There we go. And move this over, slideshow, and primary monitor, and current slide, and there we go. All right, estimating the value of a parameter. This is where we start getting into hypothesis testing, all right? If you watched the video, which all of you should have watched from last semester, it talked about P hat and Q hat. P hat is the formula X over N, and Q hat is the complement of P hat, just like Q is the complement of P. So I'm not going to go over that again. You should have seen that in the what you call it. Okay, so obtain a point estimate for the population proportion. Construct and interpret a confidence interval for the population proportion. Determine the sample size necessary. These are three important things. You don't have to write them down because you're going to write down how to do it in a minute. That's important to hypothesis testing. It's also three things that you're going to see on a standardized test. Okay? Again, P hat is equal to X over N. Q hat is equal to the complement of P hat, 1 minus P hat. So if you didn't do anything Thursday and you didn't watch the video, then at least write that down because you're already behind. P hat is equal to X over N, and Q hat is equal to 1 minus P hat. Just like Q and P that we did in chapter 6. Okay? So it's nothing new. We're taking it away from 1. N is always your biggest what? Number. So if you got 200 people surveyed and 75 say that they have purple hair, then that means 75 over 200. So if you survey 100 people and they say they drink white milk in the mornings, then 25, that'd be 25%. So that's pretty simple. All right, they're going to, same thing here. Ask 1783. So P hat would be 1123 over what? 1783. Okay, so write that down. You don't have to write down the whole schmeal. Just say N is equal to 1783. X is equal to 1123. What's P hat? P hat is 1123 over 1783. And then Q hat would be the opposite of that. So there it is. So what is Q hat? Q hat is 0.37. So make sure you write down Q hat. Why do you need Q hat? Same reason you need Q. For formulas, that's all. So P hat is 0.63. Therefore, Q hat is 0.37. What is a confidence interval? Well, do y'all remember back in Unit 1 where I told y'all that the standard deviation was kind of like a spread and that you add 1, 2 standard deviations to the right and you add 1, 2 standard deviations to, and you subtract to the left? Y'all remember that? Well, you're going to do the same thing here, only now you're going to have just 1 on each side. And you're going to have the P in the middle. What are you talking about? We'll get this out of the way. P hat is in between whatever you got on this end, and that's going to be P hat plus the error, or minus the error, sorry, and P hat plus the error. So E, capital E, is margin of error. Now, margin of error is where you start getting into those, when I told you about graphs and polls that they put on TV, You got to watch two things at the bottom of the poll. What do you got to watch? How many they surveyed, which is N, and then the margin of error. Anything above 3 is useless. So if they put up a poll and it says N is equal to 50 or N is equal to 100 and margin of error is 7%, then you might as well not even look at it. It's subjective or it's not accurate. What does subjective mean? They're trying to get you to believe something by looking at this poll. That's called subjective polling. Is it real? Hell to the yes. It is. Okay? The media is great, but when the media is crossed over to propaganda, that's when you got to watch it. I don't care if you're looking at the news, if you're looking at a magazine, if you're looking at a newspaper. You've got to look at the material, and then if you don't understand something, do you believe it or do you research it a little bit more? You research it a little bit more. You don't believe it all the time, because sometimes advertisers, how many times have you seen people get rooked by a car salesman or an advertisement or an ad in a paper or a piece of mail that you get? You know what I'm saying? You get a free car. This key will fit. They put that in and all it is get you up to the Ford place or whatever, so a car salesman can try to steal your car from you and trade it in on a new car and get you in $15,000 worth of debt. That's what they're trying to do. Okay, so you have to. Knowledge is what, and you are your own decisions. Okay, so if you end up in a box in a ditch down by the river, it's because of those two things. Decisions that you make, and knowledge is power. So, here is the margin of error. That's what margin of error is. It is the p-value. So let me give you p, what was that a while ago? Point what? 0.67. And let's say, whatever, I don't care. And let's say that the margin of error is 3 percentage points. So what's on the upper end, or the lower end? 0.64. What's on the upper end? Okay? This is called a confidence interval. The confidence interval is basically the margin of error with the p-value. That's what a confidence interval is. So that's this guy. Confidence interval is based on the confidence level. Write that down. The confidence interval is based on the confidence level. Now, you may have seen this in the video because I may have went to chapter 9 because 8 is really useless. Okay? You have a couple of things in 8 that's important. The rest of it's useless. All right? 9, I want everybody to, I don't know if y'all saw this, but make an index card. Did I go through this in the video? Huh? I heard, Was that a yes or a no? I can't decipher mumble. Okay, nobody's going to say. Anyway, get you an index card. And we're going to go into this in a few minutes later. A big index card is best. And we're going to divide it into sections. And we're going to put our level of confidence from 91% or 90% to 99%. Okay, now 2 questions I'm going to ask you here. Why haven't I put below 90%? Because I've taught everybody throughout the whole semester, all my students, about raising the what? Raising the bar. You don't want to half-ass do work. So why don't I put 78% and 73%? Because below 90% confidence level, if you're doing a quality assurance job, is half-assing your job. You don't want to go into a presentation and the boss or the chairman of the board says, well, what is the confidence level? How confident are you? Oh, I did this on a 78% confidence level. Why don't you just hang a sign around your neck that said, I'm lazy as hell, okay? Or I don't want this job. Because guess what? You're going to get fired, all right? So why do I say above 90? because you want to be above 90% when you present anything. And when you are receiving a presentation, they're going to say a 90% confidence level, which means 5% confidence interval. 5%, plus or minus 5%. You understand what I'm talking about here? Okay. Why do I not say 100? Because you're never going to. I don't know what the rest of it was, but the first part was right. You're never going to. Okay. Does anybody want to take a second stab at that?
You're never going to be 100%.
You're never going to be perfect. Okay. Now I know there's 2 or 3 people in here that think they're perfect, but you're not. Okay. And you don't know it all, whoever you are. Okay. The water walker. There's a reason I call them water walkers. Okay, because there was only one water walker. Pass the plate and put the fried chicken out. Okay? But anyway, if you go 100%, you're fooling yourself because you're not going to ever reach perfection on a mathematical problem. Okay? You with me? Because basically you're saying impossible or you're saying impossible, depending on the context, or you're saying perfect. Whichever the context of the question is, and there is no 100% because there is no perfection, and you can't say what? Impossible. Okay? So, the confidence level on most of my questions will be 90 to 99%. Will you get a homework question that says 78%? Yes. You'll get a homework question that says 64%. I'm not interested in those. Those are just practice for you. If I test you on the confidence interval and the confidence level, it's going to be based on 90 to 99%. And the confidence interval is based on the what? Confidence level. Okay? I am 95% sure that the blah, 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 blah is going to fall between blah, 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 blah and blah, 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 blah. That's where we're heading with this. Okay? There we go. 95% confidence level. This is where we get into the card. All right? You're going to do 2 or 3 things with this card. First, you got to draw it. Of course, I can't draw all of it on here. We're just going to go ahead and start with the first part. All right, this is 90. The 90%, this is 99%, and y'all can figure out the middle, okay? First thing you got to do is find alpha. Did it go to the next? Oh, I got to draw all this again. There we go. Sorry. I'm not going to draw everything. I'm just going to draw 90% and 99%. And this is called the confidence level. They say level of confidence. That just makes them sound smart. Okay? It's confidence level. So at 99%, first thing I got to find is alpha. Alpha is going to be the complement of the percentage. So what is the complement of 99%? 1%. So alpha is going to be 0.01. Everybody with me? You can put 0.99 if you want to. I don't care. All right? Let me erase this because this looks awful. Can I erase? Now see, that's interesting. In 137, I have 2 buttons to erase. I have erase as I just did, and then I have erase the whole page. And this, I don't know, damn Russians. That's their fault. So at 90%, what is alpha? 10.10. So at 95%, what is alpha? 0.05. Everybody with me? Okay, now I want you to start filling out an index card. Don't have to do it right now. I want you to get a big A index card, not the little small one like that, because it's going to, okay, get a big one like that. And I want you to bring it to class next time, and I want you to start filling out these two columns. The next one is going to be alpha over 2. So what's half of a cent? 0.00 what? 5. So alpha over 2 would be 0.005. What's half of 5 cents? 0.025. And what's half of 10 cents? Okay, so I want you, your homework, part of your homework, I want you to get a BA index card, and I want you to do it right and organized. I want you to go ahead and do the first 3 columns. Try to keep them kind of small like I did, because you got 3 or 4 things you're going to put out here. It's not a big deal, but a couple more things you're going to put out there. Not a big deal. But anyway, fill those out from 90 to 99, and then fill out alpha, and you're going to look up this area. I'm going to put a 0 right here. What does that mean? That means this is an area. And I do inverse norm. Somebody do inverse norm for me right quick. Get your calculator out. Do inverse norm 0.0050. Tell me what you get. And that's going to be your z-score.
Negative 2.5.
Don't worry about the negative. What is it?
2.58.
Okay, do 0.0250.
From 1.96.
And do 0.0500. .0500, 5 cents. 1.67.
64.
1.64.
I don't know.
Okay, now this basically that z-score is what you're going to need. So you need to do that. Type in inverse norm of this one. I think that's all you need. I can't remember anything else you need. So you just need 4 or 5 columns. Okay, so in this case, a 95% level. Now, why do I want you to do it on your index card? Because what did I tell you I was going to give you on the test? 90 to what? So you won't have to go through and do this on your what? Calculator. That's extra time. So that's why you need this. Okay? So implies that if 100 different blah, 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 blah. I don't know what they're going to show here, but I really don't care because that's what I wanted to show you. Ouch. All right? Point estimate, plus or minus. That's what I showed you a while ago. P hat. This is a fancy way of saying P hat is in the middle of what? P hat plus margin of error. And then P hat what? Minus margin of error. That's the same thing as point estimate plus margin of error. Okay? So you can write the confidence interval as point estimate P hat plus or minus E, or you can write it like that. P hat plus or minus E is what this is saying. Okay, people are convulsing. Or what time is it?
9.
Okay, it's not time to go? Okay. Yes, ma'am.
On the index part, how far do you want to say the lead?
I'm sorry, what?
On the index part, how far do you want to say?
Just go 90 to 90 and just go to the z-score. So 4 columns. I thought there was a 5th column, but there's not. Okay? Now all of this stuff is crawling. We get to the walking later. Okay? So just bear with me. Sample size. These are all things that we're going to be finding. These are 3 things that we're going to be finding. The sample size, standard deviation, the level of confidence. We already talked about the level of confidence. Sample size, probably going to be, one of these is going to be on the next page. Okay, sample and distribution. Write that down because that's in chapter 8, I believe. And I don't write it that way. How do I write it? The sampling distribution, blah, 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 is equal to the square root of PQ over N. That's the way I write it. Now, also, make sure you make a note of this. And I don't have highlighter on this either. I don't understand. Must be a different version. Write this down right here. In order for you to be able to do these kinds of problems, NPQ has to be above 10. NPQ has to be above or equal to 10. Now, most of the time, it will be, okay? But there'll be a few, like on a standardized test, and they'll give you a big, long paragraph, and when you type in NPQ, you get 8. Well, you can't do the problem. If you take NP and Q, and you get 8, you can't do it. Okay? And make sure that you check this out. We also, when sampling from finite population, N has to be less than 5% of big N, which they're going to give you that. I'm not really worried about you understanding it right now, because when we get to doing the problems, there's like 5 or 6 steps, and you're going to do all this in those 5 or 6 steps. So it's not really like you got to know it right now. What'd y'all say at the time it was?
It's 9 o'clock.
9 o'clock? I mean, what?
It's not.
Okay, 9 o'clock. All right, we already talked about confidence interval. We talked about 1 minus alpha. We already talked about that. I'm not worried about that. There we go. Lower bound and upper bound. This is where you find out how, where your upper bound and lower bound is. Now, this right here, this is margin of error. I don't like the way they do this, so I'm going to give you this. There it is. Write that down, margin of error. The z-score in the 4th column of your index card is going to be that number right here, z. You don't need to write the alpha over 2. It's the only time we use a z-score, so just z. Okay, that's the z-score that's on your index card. 90% confidence level, 1.64. 99% confidence level, what I say, was it 2.56? What was the top one?
2.58.
2.58. Now, why am I using the negative? It's using the distance. Okay, it's not the absolute values. Don't worry about the negative on these z-scores. You just got to worry about the z-score. And I'm going to rewrite this because I don't use 1 minus p because that's aggravating. So E, the margin of error, is equal to z times the square root of p hat q hat over n. Okay, so that's about the 2nd or 3rd formula that you need to know for chapter 9 and 10. About 3 formulas and your index card. They're probably going to give us an example next. Anybody ever heard of Quinnipiac? Anybody ever heard of it? No, of course not, because you don't watch what? The news. Quinnipiac, I can't even pronounce it, is a very famous polling service. Okay? This right here, you need to research it. Okay? Please work with me, please. Okay. I'm sorry, I'm talking to the board. This right here, all they do is polling. That's all they do. Okay? Another one is called, can't think of it right now because I just went blank. But anyway, there's many of these. And all they're paid for is to go out and survey people. All they do is go out and poll people. Especially during what time? Election time. Oh, I'm not used to people actually knowing that. Okay? Usually during election time. Is Quinnipiac, is it very reputable? Yes. I can't think of the other one right now. Rasmussen. Write down Rasmussen. Spell it the best way you can. I don't know how to spell it. Ras, R-A-S-S, Musin, M-U-S-I-N, I guess. I don't know. Those are 2 of the most popular polling institutions that there are. Okay? And in July of 2008, asked 1783 whether they favored the opposed death penalty. Boom! 90%. There you go. So at that point, you've got 90%. That means 0.10. That means 0.05. And that means 1.64. So that's your Z-score. Boom! You already know it because you got your index card.
So they're only normally going to use 99, 95, 9.
I know.
Okay.
90. You got to fill in the other one. 92, 93.
Yeah, I know. I'm saying
Okay.
what I'm saying.
I'm going to use that on the test. If you have 78 on a homework question, then that would be 78% or 70. Let's use 70. What would complement 70 be? 0.3. What's half of 0.3? What's half of 30 cents? And then add 2 zeros. Now somebody do the inverse norm of 0.1500.
1.04.
1.04.
Yes.
So that's what you would use for a Z-score. These are mostly going to be homework questions. All right, so here we go. First, find p hat. What is p hat? P hat is x over n, which is 1123 over 1783. That looks familiar. We've done that before. 1123 over 1783, which is 0.67. Did we not say that a while ago?
It's 6.3.
6.3. So therefore, Q hat is equal to 0.37. That's the first thing you got to find, P hat and Q hat. This is a test question. It's kind of like a test question, one of the first ones, because there's like 4 or 5 parts of these when we get through. Okay, we're doing like the first part. 90% confidence level gives me a Z-score of what? 1.64. So, margin of error is equal to 1.64 square root of 0.63 times 0.37 divided by, what's n? 1783. Somebody crank that out. Now do the inside of the radical first, then raise that to the 1/2 power, then multiply that by 1.64. And since there's so much calculations there, I'm going to wait till 2 or 3 of y'all get the right answer, concur with each other. I don't want somebody setting me up for failure. What'd you get?
0.01. How many numbers will go?
0.01, just give me 3 because this is a percentage, right? So you got to go to 2 decimal places. What'd you get? What'd you get?
0.0188.
0.02. Okay, one more 0.02. Okay, so this comes out to 0.02, which is 2 what? 2%. So your margin of error is 2%. On a poll, is that good?
Yes.
Yes. You know that this poll is worth, then you look at n and see if n is above 100. If you're running a national poll, shouldn't n be over at least maybe 1,000? Yes. Shouldn't be 100. Okay? So what is our confidence interval? Well, 0.63, 63 cent. And then what's 63 cent plus 2 cent?
65.
And what's 63 cent minus 2 cent? And that's your confidence interval. So your confidence interval is going to be between 0.61 and 0.65. Now that's going to be where your p hat will fall at a what percent confidence level?
90.
So if your p falls at 0.64, then you're 95%, you're 90% confidence. Now of course, 90 is really low. Okay, standards. You want to raise the bar, you at least want 95% or more to make it worthwhile. Now what are you doing? Well, what you're going to end up doing is you're going to take all your data from a sample and you're going to crunch it and crunch it and crunch it and run it through this math, and then you're going to say, I'm 95% confident that the average age of the Tri-County Tech student is 26 years old based on the sample at what? Anderson campus. See what, that's where we're heading with this. Okay? Therefore, the sample predicts what? Population, without having to waste time and what? Money. Capisce? Now again, the math is not that hard. You just have to know the method and you have to read. Is that what we just did?
Yeah.
Okay. So I'll leave that on the board for a second. I don't know if you need it or not because we just did it. Now I don't do it like this. I don't do it like this because that confuses people. Okay, it says 1.645. So that needs to be 1.6. You can leave it as 1.645 or it needs to be 1.65. You need to use one of those two. We use 1.64. But
Yeah, nobody gave us that same answer.
what?
They gave us the same answer.
Okay. All right. Well, use it however you. I would use 1.645 on my card though. I thought y'all said 1.64 and thought that was it, but it's 1.645. We are 90% confident that the proportion will fall between 0.61 and 0.65. We just said that. Okay, let's rewrite this one. This is another formula that you need. This is about your fourth formula. N is equal to P hat Q hat times Z over E raised to the second power. Now, a while ago I said N should be 100, at least 1,000 for a national poll, right? What decides that? This formula. If I wanted to have a 95, I want to have a 99% confidence level. Let's do a 99% confidence level. Well, 99 confidence level means 0.01, which means 0.005, which means, what was the top one? 2 point what? 2.58. So there's my Z. So if I want a 99% confidence level, my Z is going to be 2.58. And of course, I don't know any P or Q right now because, 75% of the population, that'd be 0.75 times 0.25, and then 2.58 over the margin of error. Let's say we want a 3% margin of error. Then you plug that in there, and you get a BA number. Now, is there anything such as 0.5 people or 0.2 people?
No.
So you always round up no matter what you get. The only way that you use the number given, if you get 150.0, then it's 150. If you get 150.1, it's 151. If you get 150.8, it's 151. Any decimal rounds what? Up. And that's because there ain't no such thing as a half a person. So you round up. Anyway, they're going to probably tell you that in the next couple of slides or whatever. Did we not just do that? Am I going backwards or forwards? Okay, this one is when you don't have an N or a P. I mean a P or whatever. If prior estimate is unavailable, write that down. Because sometimes in the questions, they will not give you a P hat or a P. They won't give it to you. If they don't give it to you, you're going to use 0.25 because what's 0.5 and 0.5? What's 0.5 times 0.5? 0.25. Talking about, flipping of a coin. You don't need the p-value for flipping of a coin because what is the p-value? 0.5. So there are some that you don't need p. And when p is not given, you just assume 0.25. So this would be, so you got another formula. The margin of error always be expressed as a what? Decimal. And I told you that a long time ago. Here we go. A sociologist wants to determine the percentage of residents of America that only speak English. What size sample should be obtained? What size sample should be obtained if she wishes her estimate to be what? 3 percentage points. So E is equal to 0.03. 90% confidence level, Z sub 90 is equal, what did we say it was, 1.645? And she uses the estimate, which is P, or P hat, 0.824. Therefore, Q hat is equal to 18176. Somebody check me. Now, find N. So N is equal to 0.824 times 0.176 multiplied by what? 1.645 divided by what? All right, crank all that out. Should you get a VA number? You should get a VA number compared to the percentage, yes. Whether it's 155 or 1,055, it should be a big number that you're going to have to survey or poll. Somebody tell me what you got.
436.
Okay, was there a decimal?
Yeah, 435.97.
435.97. There's no such thing as 0.07 person. There's no such thing as 0.97 person. So either one of those would be 430 what? Now, what's the law of large numbers do? Cover your what? Backside. Okay? Cover your ass. So if I was a lazy person, I'd go, oh well, I just need to do 400 people. But what if somebody, tell me what somebody would do if they were raising the bar, not lazy, and covering their butt? How many would they poll? Good job, 500. Exactly. You always round up, but you're not going to, but the person that just gets by is going to do 400 or 436. The person that wants to do a good job will do 500. Okay? So, even with just a small time poll, you're gonna at least do 500 people. So when you see a national poll on national TV that polls 100 people, what should you think? It's garbage. Isn't it nice to know stuff? It's a whole lot better than being ignorant. Ignorant. You don't know what ignorant and ignorant is 2 different words. You know that, don't you? Ignorant, I-G-N-E-R-T. That means you dumb as you know what. Ignorant means that you're not as dumb as ignorant. Y'all got that? Same thing with whooping and whipping. A whipping. I'm going to give you a whipping, Junior. That's a little bit more than time out. But what's a whooping? You're getting your butt tore up. Same thing with hungry and hungry. There's a difference. And Clemson and Clemson. There's a difference. Where are you from? Powdersville. I'm from Powdersville. I'm from Belton. You can always tell a transplant, can't you? I'm from IPA. Okay, so let's talk about what y'all need to be doing. Let me turn off the handy dandy recording.